We use a system called E and Z notation, with one isomer being called the Z isomer and the other the E isomer. To give E and Z names, it is first essential to determine which atom or group we are going to use on each carbon as a reference point. To do this, we assign a priority. CIP, or Cahn Ingold Prolog Rules, are followed. Basically, we look at the two groups bonded to each carbon and decide which one is more important in order to help us name the isomer. The highest priority group is normally the one that has the highest atomic number. For example, if you have a chlorine and bromine group bonded to the same carbon, the bromine has a greater atomic number and will be considered the higher priority. If this isn't possible and the two atoms bonded have the same atomic number, for example, two carbon groups, then you look at what those atoms are bonded to themselves and compare their atomic numbers. For example, if you have a CH3 and a CH2CH3 group bonded to the same carbon, the CH2CH3 group will be given the highest priority, as here the carbon is bonded to another carbon, whereas the carbon in the CH3 group is only bonded to hydrogens. Once each highest priority group is assigned on each carbon, we can now compare their orientation to each other. If both groups are on the same side of the double bond, we call it a Z isomer. Z comes from the German word for together. I personally remember it as Z for same, as in same or same side, but whatever works for you. If, however, both groups are on opposite sides of the double bond, we call it an E isomer. E comes from the German for opposite. If you remember Z for same, then you know E must be opposite, as there are only two possibilities. So you don't need to waste time learning two ways of remembering it. For example, if we look at 2-chloro-but-2-ene, we can see there are two possible ways of drawing the molecule. To name these as either Z or E, we first need to assign the highest priority group on each double bonded carbon. On carbon 2, we have a chloro Cl group and a methyl CH3 group. The Cl has a higher atomic number than the carbon, meaning it is the highest priority group. On carbon 3, we have another methyl CH3 group and a hydrogen group. The carbon has a higher atomic number than hydrogen, meaning this CH3 group is the highest priority. In the first molecule, the highest priority groups on each carbon are on the same side of the double bond. This means this configuration is the Z isomer. Remember, Z for same side. The full name of this molecule is Z2-chloro-but-2-ene. In the second molecule, the highest priority groups on each carbon are on opposite sides of the double bond. This means an E configuration isomer. The full name of this molecule is E2-chloro-but-2-ene.